blockchain, which is an Ethereum DEP that allows the management and transfer and therefore trade of used software licenses. And today I wanted to give some of the experiences I have gained through this development and share them with you. To start off, what is license on blockchain? So what does it actually do? For this, I think you first need to understand what used software actually is, because traditionally software is purchased directly from the manufacturer, maybe through authorized resellers, but basically usually never buy used software in traditional business. However, in 2012, actually the European Court of Justice decided that the trade of used software is legal, which was a grey zone for quite some time. But they realized as well that software licenses are virtual goods and therefore posed some additional requirements to this particular trade, which means that on the one hand, the seller must make his copy of the license unusable so that he cannot sell it twice. And secondly, whoever buys a license needs to make sure that he can prove a gapless transfer chain and therefore trace his license back to the software manufacturer himself. And we as people who know the blockchain can immediately see that these are basically two problems that are solved by the blockchain or any digital ledger basically, because the first problem is exactly the problem of double spending and the second one is the open ledger. That's why we decided to develop license on blockchain, because we thought it was a perfect match. So how does it work? At first we need to somehow get these licenses that sometimes already exist or mostly already exist onto the blockchain. Therefore we need to create a digital twin, and we decided that we want this process of creating the digital twin to be open to everyone so that everybody can certify software licenses using license on blockchain. For this, he basically requests a license contract, what we call a license contract, from an LOB. LOB stands for License on Blockchain Root Contract, and that we have already deployed on the Ethereum. We're working on Ethereum, and this creates a new license contract that is dedicated to this particular issuer. Now you might think that, well, everybody can simply request license contracts and issue licenses on them. That's correct so far. Therefore we needed to add some kind of identification, authentication, so that we know who actually issued these licenses and that they are valid, and we could hold him liable for this, whatever he issues. We therefore build on top of SSL certificate and certificate authorities, because it's an existing infrastructure that is built up for websites, HTTPS, that has already solved all these problems of digital identification, authorization. And the issuer simply signs a set of LOB rules, which in short basically mean that all the licenses he issues are valid and he's not attempting to do any fraud, and puts this signature onto the license contract. After that, he can then issue licenses. This all works with our LOB wallet that we have developed, which is just a web page and works through MetaMask. I think some of you already know MetaMask, otherwise I'll go into a bit more detail later on. And once he has registered, he can simply issue license. And I wanted to give you a short live demo of how our wallet actually works and how easy it is to transfer licenses using it. So for example, right now here, I'm simply in Google Chrome, I've got MetaMask installed, and I own two types of licenses right now. One is Microsoft Office 2016 and one is Microsoft Windows 2010. Of one of them I own 175, one of them 275. And if I wish to simply transfer licenses, I can click transfer, enter an address I want to transfer the licenses to. Let's say I want to transfer 50 licenses, click transfer, and now this transaction needs to be submitted to Ethereum, which is why MetaMask pops up, which will then submit this transaction to the actual blockchain, which in this case right now is a local development blockchain I run on my computer just to keep it easy. but it will soon be deployed on the main network. It is already deployed on Hoppen. So I click submit. I can see there's a new transaction that transfers licenses from my account to this address. It is currently unconfirmed. And if we wait a bit, it should hope. It already says two confirmations. And if I want to, I can look at the transfer chain and see that I have that originally 200 licenses have been issued to me. I previously transferred 25 licenses and now transferred 50 licenses to a different address. Yeah, so that's as easy as I think it gets to really interact with this, with license on blockchain. And you don't really even see that it's backed by blockchain technology, which I think makes it really easy to use. Okay. Yeah, and this wallet is already hosted at wallet.licenseonblockchain.org. You can go ahead and use it if you set MetaMask to the Hoppen test network. So, what experiences did we gain from developing license on blockchain? First of all, I thought I'd bring some Solidity code with me. That is a simplified example of how our license contract works that keeps track of these, the balances. And I think even if you're not really into code, it's easy to understand what's going on here. So, for example, we start off with a balance that assigns each Ethereum address a number. Unit 256 is simply a number. And we can transfer licenses to a different address if the balance of the message sender is sufficient. And it's simply about deducting the balance from the message sender and assigning it to the recipient's address. Lastly, we simply lock the event just to make sure that we can later retrieve it again and build up this transfer chain. So it looks a lot like traditional software development, but I think there are some key differences, and these I would like to highlight now. The first one is, and I think we've already heard this a couple of times yesterday and today, is that once these smart contracts are deployed, you cannot take them back. You cannot run updates, you cannot run bug fixes, and that's why we think that testing is absolutely key in smart contract development. We, for ourselves, decided to use automated testing using a framework called Truffle, and this framework allows you to write automated test scripts in JavaScript that interact with your smart contract through web3.js. Framework I think is currently developed by Fabian Vogelsteller, who was here yesterday. And it sets up a fresh testing environment on each run. It runs on a local blockchain, so you can run your tests as often as you want without paying transaction fees, which is really important. Just to give you an idea, our Solidity code base consists of about 400 lines of code. That's all there is. And for this, we wrote 600 lines of inline documentation just to specify what these functions actually do, because if you don't know what they are supposed to do, you can't test them. And we've got about triple the amount of Solidity code and test code, just because we wrote every test case that we could think of, we wrote down in an automated fashion, and so we know we won't regress on it later. Secondly, we thought that no matter how many tests we write, we know that there may be bugs that we simply didn't think of. So we provided ourselves some safety lectures. And two of these I would like to highlight right now, because I think maybe if you're developing smart contracts yourself, you can adopt them to your use case as well. One of them is that we thought that it may occur that licenses that were issued using license on blockchain should be revoked because of orders, for example, by a court. Because for some reason, whoever issued them wasn't allowed to do so, or he was deliberately perceived by whoever owned these licenses. And so he was not supposed to create the digital twin. That's why we give the issuer the option to revoke licenses. It's still on the blockchain that they existed. The entire transfer history is on the blockchain, but they're simply marked as potentially invalid. The second example that I would like to highlight is that all of our smart contracts have a function to completely disable them, which basically disallows any further actions on these smart contracts, so that if we discover a serious bug or a serious flaw in the system, we can completely shut them down and maybe start over again with an updated version of the smart contracts. Just to make sure that these old, we can freeze the old state. Yeah, so much for the smart contract side. Now I showed you, oh no, sorry. The second one, flaw, I think exists, or not flaw, but problem, as opposed to traditional backends, is the limited computational power on the Ethereum blockchain. So even if you're willing to spend vast amounts of Ether on gas, that's the maximum computational amount you can use in one block. And I did some quick checks. That's not scientific at all, but that currently corresponds to about 0.1 milliseconds of compute time on a single core on my laptop, which I think everybody agrees is not a lot. That's the maximum you can do in one block. And that's why we decided to do some of the really expensive computation, like verifying SSL signatures, not on the blockchain itself, but simply offloading that computation to the wallet and simply storing the raw data on the blockchain. Yeah, so that so that we can save loads of gas cost on the blockchain and keep it feasible. Yeah, so much for the smart contracts. That's the two main points I wanted to highlight. And secondly, I showed you our wallet that worked through MetaMask. I just wanted to highlight that with MetaMask, which is a browser plugin for, I think, Google Chrome, Firefox, I think Internet Explorer and Opera as well, you can make your browser capable of interacting with the Ethereum blockchain. And I think that it means that you don't need to download any additional software. It means that, yeah, the entry barrier is as low as it has ever been. And what MetaMask then does is that it exposes the Ethereum API through a JavaScript framework that can then be used from traditional websites. And this means that actually developing this step is not that much different than developing a traditional web app. It means that you can use HTML and CSS for the entire layout, which basically all web developers are capable of. The only key difference is that you don't call your own web servers through, for example, a REST API, but that you use web3.js to call into the Ethereum blockchain. But even those are pretty similar in how they work, because it's also still asynchronous calls. You just need to think about how many transactions can you do, and think about that every transaction costs a bit. There are, of course, a couple of input fields and so on that are specific to Ethereum dApps that you don't have in traditional web apps. For example, input fields that take an Ethereum address, a selector to select which gas price you want to use for a transaction. And just wanted to highlight that there are some great packages on the Ethereum GitHub repo, also developed by Fabian Vogelsteller for the official Mist wallet, for the official Ethereum wallet, that are really easy to use and make these components zero effort as well. Yeah, and that's about it. What I wanted to say, it's just, I think that the time is really there that you can actually actively develop dApps using Ethereum. The frameworks are there. It's sometimes still a bit beta and buggy, but mostly it works. And that's kind of the message I wanted to get across. dass da eine